When I reviewed the P1000s, I said that they are an excellent and value for money pedal set with all the upgrade add-ons from Simagic. Now they have added more stuff to make them feel even more tailor-made. But usual disclaimer first. Simagic has provided this stuff for review purposes, however, all of my thoughts and opinions are free from any influence. This is the second product in Simagic's Neo lineup called P-HPR Neo and is going to be the focus of this video. For the most part. There is another add-on called P-SFP, which we will be talking about later. These will be retailing at $16 a piece or $48 for 3. That is excluding shipping and taxes. In the box, you get a small package with Allen key, some cable holders, a few bolts, a really neat manual, and the bracket. But let's talk about this. These are not a replacement for HPRs, but a more affordable haptic reactor. And similar to HPRs, you would require the control box to make them work on any other pedal set. The overall build it's alright. It's not cheap, but certainly not high-end either. The plastic shell is solid, having a good texture. Being extremely familiar with sleeper cars, I learned it the hard way to never judge a book by its cover. And whether or not these are $16 a piece will be decided by how well it performs. And also, these are compatible with Simhub, but more on that later. Let's start with the mechanism. This is a haptic reactor, which provides vibration of engine RPM, tire lockup, tire slippage, ABS, traction control, and all of that on your feet. The vibration is delivered by a little motor, which I'm sure you might have seen in a PlayStation or Xbox controller. This type of motor uses a small unbalanced mass on one end of the motor's shaft, which, when rotates, moves this counterweight along with it, creating a centrifugal force. Don't get confused here. The motor produces centrifugal force, while centripetal force acts to maintain the circular path. And given DC motors can be very, very fast, the super high rotation causes, you guessed it, vibrations. The faster it spins, the harder it will vibrate. But how does it compare to the pre-existing HPRs? You see, both the HPR and HPR Neo serve the exact same purpose, to provide haptics, but they are different at heart. The HPR Neo is more affordable because it uses eccentric rotating mass motor, which has been around for years, is widely available, cost-effective, and simple to use and work on. It does have its own drawbacks such as slower startup times or latency issues, amplitude depending on frequency, being a tad bit imprecise, and also being comparatively power hungry to LRA. And speaking of, HPR costs more because it uses linear resonant actuator motor, which in some areas is a replacement for ERM. In exchange for the extra money, you get a motor which is precise, compact, and energy efficient. Instead of an off-centered rotating mass, these motors have a small mass attached to the spring which moves in a single axis to produce more precise vibrations. Since I don't have the HPRs for a direct comparison, my insights will be based on theoretical knowledge and some research. Now a full-blown physics lesson is about to take place, so feel free to jump to other segments unless you're somehow allergic to physics, of course. Most ERM motors are unidirectional, meaning they can only spin in one direction. This, however, is bidirectional. I haven't been able to understand when and how it decides to spin in the opposite direction, but all I know is that it does. A bidirectional ERM motor has some advantages to it, such as even wear and tear on the motor, a more refined vibration output, and the ability to generate a more complex vibration pattern. Now, when talking about vibration, we also have to talk about vibration amplitude and vibration frequency, both of which are simply a specific aspect of amplitude and vibration. Let's make all of this a bit easier by a diagram, where this line represents the resting position. The wave has traveled upwards and downwards in one vibration cycle. The distance between resting position and maximum distance traveled is vibration amplitude. Vibration frequency is simply the number of oscillations or cycles an object undergoes in 1 second. For example, 10 Hz means 10 vibration cycles per second, while 50 Hz means 50 vibration cycles per second. Higher frequencies result in smoother output, but increasing it excessively can make the vibrations less effective, leading to diminishing returns. Usually, frequency does not depend on amplitude, but in case of an ERM motor, frequency and amplitude are linked. Because in a rotational system, you cannot make changes to one variable without disturbing the other. Meaning, it is impossible to feed more voltage to increase vibration intensity without making changes to the motor speed, thus making vibration frequency and amplitude increase exponentially. Or, like I mentioned, the faster it rotates, the harder it will vibrate. This type of mechanism has its own challenges, as increasing the speed of motor to further boost vibration intensity can lead to diminishing returns due to mechanical limitations. Beyond a certain point, the vibrations may actually become less effective, making it harder to find the correct balance between speed, or frequency in this case, and amplitude to achieve the desired haptic feedback. I'm quite certain that an LRA motor will be marginally better than this. Since I haven't had the opportunity to test it myself, it would be unwise to make assumptions. However, based on the inherent nature of the motors and the help provided by mother physics, at least we can decipher what to expect. But why are we talking about all of this? To understand that this design will have a little bit of lag or delay. This delay is going to be in milliseconds, but a delay is a delay if perceptible. So let's find out what Simagic did to reduce it. While testing tire slip, lockup and gear shifts, I noticed an inconsistency in feedback delivery between Simpro and Simhub. Both were doing good, but in different areas. I sat on it for days before deciding to finally investigate the differences. I chose to conduct the test on upshift and downshift times because it was easier to capture both the input from the game and the reaction time of haptics using a single camera, resulting in less margin of error. Using two different cameras would have introduced more inaccuracies due to the challenge of syncing two clips together perfectly to the last millisecond. I set the frequency to 35 Hz, pulse duration to 30 milliseconds and the strength to 75% on both Simpro and Simhub. Then recorded the upshifts and downshifts using my phone at 240 frames per second and checked the delay in response frame by frame on my laptop. And before we begin, keep this in mind that the data being provided here will vary every single time and with each activation/repetition. We'll be taking average latency time, so feel free to pause the video to take a better look. Starting with upshift times in EAWRC. While there is a difference when shifting from neutral to first, I wouldn't say they are too far apart. But downshift is where you see a difference. After combining the upshift and downshift times, Simpro is outperforming Simhub by providing an average latency time of 16.08 milliseconds compared to 30.63 milliseconds. On Assetto Corsa, it is evident that Simpro is lagging behind. If you think upshift times are not optimal, take a look at downshift times. Combining the upshift and downshift times again, you get an average latency of 31.02 milliseconds on Simhub and 123.48 milliseconds on Simpro, making Simhub more consistent. Let's take another example, Dirt Rally 2.0. I felt that Simpro provides feedback almost instantaneously compared to Simhub. Upon further investigation, I found my feelings to be true. Combining the upshift and downshift times again gives Simhub an average latency of 52.26 milliseconds and Simpro 26.51 milliseconds. Simpro is the one to have lower latency, which translates to a more consistent feedback. This method isn't the most accurate due to several factors such as game's frame data, monitor's response time, limitation of my camera, etc. etc. At best, it serves as a decent approximation. However, the takeaway is that it highlighted the inconsistency in latency, proving that it is dependent on a couple of factors. First being the inherent nature of the motor. Like we discussed earlier, ERMs rely on the mechanical movement of the mass to generate vibrations, meaning A, the starting position will vary every single time, and B, the time it takes to reach the desired speed and vibration amplitude won't be that consistent. And second, based on the data I have and what I have experienced, it seems like a software issue. I might not have the fastest reaction times, but if I can feel it, you're likely to notice it as well. Now don't get me wrong, this latency issue isn't as bad as it sounds. This test simply proves inconsistency in feedback delivery. What matters more is the experience while gaming. As a person who was provided with this product, I had to be thorough. Now let's talk performance, shall we? Initially, my experience with these was a bit underwhelming due to my lack of familiarity with haptics. Pair that with the buggy early stage software and you've got a recipe for a less than ideal first impression. Over time it got stable enough for me to figure out what I was looking for. The adjustable frequency range is from 10 to 50 Hz. 10 Hz will provide noisy and rough vibrations, while 50 Hz will provide a smoother output. You also get to adjust the duration of vibration and the range is from 0 to 1000 milliseconds. These motors are powerful enough to numb your feet after a few laps, at least on socks. So I advise against maxing out their strength. Instead, carefully tune the frequency and strength levels that complement your driving style. While these motors will produce vibrations, your focus should be on the feedback that a standard non-motion rig lacks, such as ABS, tire slip and lockup. I know both tire slip and lockup can be felt on a wheelbase fairly easily, but receiving the feedback on the feet brings the simulation a step closer to realism. Now starting with the thing that I was most looking forward to, clutch bite point feedback. If I'm not wrong, I don't think any game provides bite point data. So you have to manually set the percentage where you want the reactor to vibrate for each game and then make it work. It sounds like a lot, but you only have to set it once. Moving on to track racing games, I only used tire slip and gear shift. While tire slip frequency was occasionally helpful, I did not actively rely on it. In about 7 out of 10 instances, wheelbase helped me out with tire slip data. And the remaining 3 out of 10 instances, haptics played a crucial role in saving my car. The time it takes to deliver the feedback might not match your wheelbase, but it was helpful still. For example, I started braking too late here, and haptics delivered feedback quickly and at a very early stage, which helped me to save the car. Tire lockup is good too, but I did not use it much to be honest. Although the inconsistency of the haptic motors can be mitigated to some extent with software updates, they still won't save your vehicle every single time. It is important to understand that even with HPRs or a proper motion simulator, mistakes are inevitable. These products help reduce error, not eliminate them. In rally games, I don't use ABS, so feeling the tire lockup alongside slip proved to be helpful at times. Also, I came across a very neat thing which I absolutely loved. If you somehow manage to blow your tires, these motors will provide a very distinct and continuous vibration based on tire lockup/slip. The rim getting dragged on the road and it trying to rotate feels quite good. I would say the wheelbase and haptic motors were working in somewhat of a synergy. There were a few slightly delayed vibrations here and there, but overall it was great. I also enabled gear shift vibrations, so every upshift and downshift provided feedback that helped me connect with the car even more. The vibration was making it feel like the gear was engaging mechanically. I don't know how realistic it is, but it felt great. Since rally cars don't have insulation, I assume gear shifts and similar sensation wouldn't be dampened at all. Anyways, I was looking forward to having fun with haptics in BeamNG, but it did not work. Similar was the case with American Truck Simulator. Euro Truck Simulator 2 worked just fine. Maybe a future update will fix this, but as of now, if you want haptic feedback on these, Simhub has got you covered. While both softwares are quite capable on their own, the majority still prefers Simhub. Simpro has 8 adjustable areas which would satisfy most users, but if you are looking to tune it further, I recommend giving Simhub a try. Not only you get access to other adjustable areas, you also get to refine the settings further for a more customized feedback. However, keep this in mind that not all of these will work on every single game. Some require additional equipment, while others are available on very specific titles. When comparing both the softwares in their current versions, the biggest advantage Simhub has over Simpro is the support for games. Like I mentioned, BeamNG and American Truck Simulator provide no haptic feedback at all, but with Simhub, it worked effortlessly. Road rumble, tire lockup, RPM, gear shifts, all of them worked. Simhub's traction loss really comes in handy as well. If you're pushing the car or carrying a lot of speed into a corner, you'd be able to feel if a big oops moment is incoming. But Simpro has one implementation that Simhub does not. Simhub vibrates on all gears, including neutral, but Simpro skips neutral. It's a very small thing, and in my opinion, it's stuff like this which matters. Anyways, the point is, both Simhub and Simpro are great softwares, so you can pick whichever you feel comfortable with. Now finally, let's talk about the second add-on, P-SFP or Standard Faceplates. I'm not sure why it is called standard faceplates when the older one should be referred to as standard. Don't you think the name straight faceplates is more suitable? Anyways, some users reported their feet slipping with socks and shoes with the old plates because of its convex shape. So this is going to help in that regard. These are going to retail for $35 for 3 plates and $29 for 2. The overall texture of the plate is finer compared to the old one. And if you are an active member of Socks Gang or the Unapologetic Barefoot Gang, chances are you might find these more grippy. If you ask me, I haven't had any issues with either of these plates. The shape and dimensions are mostly the same compared to the convex plates, except having a little cutout on the bottom corners. And that concludes this video. I'd like to thank you for taking the time to delve into all of this with me rather than settling for a straightforward answer. Let me know your thoughts on the new add-ons. I've been Dad Snape, and may the downforce be with you.